Okay, now let's look at how to generate random numbers from other distributions. So right now, with the rand between, we generated random numbers from a discrete distribution given by this frequency table that was given to us. So that was according to this probability distribution. So what if we want random numbers to be simulated from a variety of distributions? So you have uniform distribution, normal distribution, exponential distribution. So how do you generate numbers from those distributions? So you have uniform distribution, which is a continuous distribution, and it is symmetric, is bounded in both ends. So you have a lower limit and an upper limit. Okay, and it is symmetric because the probability is uniform throughout the lower and the upper limit. Okay, so the bound is bounded in both directions, not necessarily positive, because one of the bound, the lower bound can be a negative value. So you can have negative or positive values. So we have a function in Excel called rand, and that generates a random number between 0 and 1. Okay, and this is the key, the rand function. So that is the key for generating all other random numbers. So this generates a value between 0 and 1. Okay, and it is based on an algorithm that uses the timestamp in your computer as a seed. So you do get a truly random series. So if you use random function, okay, two different people can get two different answers, but it'll be close. It's not the same because they are random numbers, and by definition they are not the same. So what this means is that any number between 0 and 1 has equal probability of occurring. So that's what uniform distribution means. So it is a value between 0 and 1, but what if you want a random number from a uniform distribution between a lower and an upper limit? For example, if the time between failures of a machine breakdown is anywhere between 50 and 100 hours, uniformly distributed. So we have a lower limit of 50 and an upper limit of 100, right? So how do you generate random number in this range, which is continuous? So all we have to do is to select the lower limit plus a random number generated between 0 and 1 times the range. So that will give you, so lower limit plus, all right, the range, upper limit minus lower limit, right? And then you do a rand. So this will take the rand value between 0 and 1 and then map it into this larger range between 50 and 100. And you'll get a random number between 50 and 100. Okay, rand between, we've already seen that, and that of course gives you a whole number. Rand between gives you a whole number. It doesn't give you a non-integer values. So it's between 100 and 199, just whole numbers. Now what if you want normal distribution? So normal distribution is again a continuous distribution. It is symmetric. It is not bounded in each end, because theoretically it goes from minus infinity to plus infinity. It can be positive or negative. The two parameters that you need are the mean and the standard deviation. So suppose if you have time between arrivals is 100 minutes with a standard deviation of 10 minutes, okay, for example. Then, so this is the function that you would use. Okay, once again, it's based on the rand value, which substitutes for probability. Because it's a value between 0 and 1, this gives the probability, and you use that probability in the normal distribution to get a value of x. So this will be norm.inv. So you're using it in reverse. You're getting the x value. So rand is your probability. Okay. And then the mean, comma standard deviation. So this will give x value that follows normal distribution with probabilities generated by that rand function. Now what if you want exponential function? Oftentimes the time of a service, okay, a customer service call, how long does it take to serve a customer, that oftentimes follows exponential distribution. Empirically you can see that. So how do you do exponential distribution? Now let's look at how to generate exponential random numbers from an exponential distribution. Exponential distribution is again continuous distribution. It is not symmetric, so that's not right. So that's not symmetric. Okay, so it's going to be something like this. Okay, it is bounded on the left side, okay, because it cannot be negative. The values from exponential distribution cannot be negative. Okay, and this is the formula for exponential probability. So what is the probability that the random variable is less than or equal to t, the time taken for the next event? So here it will be like, how long does it take for the customer to be served, or how long does it take for the next customer to arrive, or next breakdown to occur. So how long is the time? So the probability is given by this formula, where mu is the average number of events in a time period. Suppose if on the average you get 5 customers in 1 hour, okay, for example, right? So mean per 1 hour is 5 customers. Then we want to generate, based on that average, we want to generate customer times, the next customer time, the next customer time, the next customer time, and so on, right? So if you take logarithm for both, if you need to do a little bit of manipulation here. So if you bring that part over this side and that over that side, so you get 1 minus the probability. Remember, the cumulative probability is going to be given by the rand function, right? So if you exchange these two, so you get 1 minus rand function on this side. All right, so you have e to the minus mu to the power of e to the power of minus mu t. If you take logarithm on both sides, you end up with minus mu times t, because logarithm will cancel out e, right? So you will have okay, so minus mu t. So remember, this side will be 1 minus probability. So you've already taken logarithm. So ln of 1 minus p, the probability, so which is going to be our rand function, right? So now if you divide this by minus mu, you get the time t for that given probability. So that's what we have to do. So we have a mean, whatever that mean is. Okay, you generate a random number. Okay. So now what we need to do is find ln of 1 minus that random number. Okay, so that's that part. So divided by minus mu. Well, we can divide by that and put a minus in front. That would be the same thing. So now we have random values of t from exponential distribution with the same time unit as the period that we used here. So if this is supposed to be 5 customers every hour, then this t that we get is hours. And then we can convert it to whatever we want, minutes and days. So that's how you will generate exponential random numbers.